Alright guys, today's goal 2.4, solving linear inequalities. Okay, so it says showing a number line. This is all values for x such that x is greater than or equal to 3. So you put the little box at the 3, greater than or equal to. Let's take a look at the next. Now here this is just the set of numbers x such that x is greater than 3. So instead of that, it's the parentheses. Okay, or you could have done open circle here, filled in circle here. Those are your possible options. Okay. So, if we look at these, this right here, this is called set notation. Another way we can write this interval using, this is interval notation. Okay, so let's take a look at some of these here. So what this is saying, this means 3 is included, infinity is not, and it's always like that with the parentheses. So parentheses means does not equal, bracket means does equal. Okay, let's do some more examples. Alright, it says write using set notation and interval notation. X has values for all numbers between 0 and 5. So set notation would be between 0 and 5. So hold on. That means the x is between. So you have 0, x, 5. It's not the parentheses, it's the little... And then interval notation, 0 to 5. Because it doesn't equal either. Okay? Now these, so one more. It says x has values for all numbers between 0 and 5, including 5. So set notation would be x bar and then 0, x less than or equal to 5. And interval notation, 0, 5. The addition property here means if you add the same thing, it doesn't change anything. If you subtract the same thing, it doesn't change anything from either side. So let's look at these. Okay, it says solve this. 7 plus 3x is greater than 2x minus 5. So the first thing I do, I look at the smaller, I get rid of it. So I subtract 2x. I get 7 plus x greater than negative 5. Subtract the 7. X is greater than negative 12. So we graph it, so it's greater than, so it should be this way, and then, whoop. Okay. Let's look at some more. Alright, it says example 4, it says negative 12 is less than x and x is greater than negative 12. Mean the same thing. Negative 12 is less than x and x is less than negative 12 do not mean the same thing, so use caution, okay? Now, the next few examples, guys, hold on. So here, these next examples with multiplication property, they're already done for you in your book, so look through them, okay? And then we'll get down to this right here, okay? Alright, so I actually forgot to give a little room, so we're going to work on this one over here. So we have distribute 5x minus 15 minus 7x greater than or equal to 4x minus 12 plus 9. Combine like terms, you get negative 2x minus 15 greater than or equal to 4x minus 3. I'm going to add the 2x, add the 3. Negative 12 is greater than or equal to 6x divided by 6. You get x is less than or equal to negative 2, or write it this way. So, if we're looking at this, interval notation, or set notation, you get that. Interval notation, it would be negative infinity to negative 2. It can equal it, it can't. Okay? So, let's take a look at some more. If you have two inequalities joined by the word and or the word or, you have compound inequality. If the compound inequality is joined by the word and, then the set of conditions when both the answer sets are met must be met. This is called a conjunctive inequality. Okay? If the compound inequality is joined by the word or, then all the conditions must be met. This is called an injunctive or disjunctive. Okay? So again, conjunctive is the and, disjunctive the or. Okay? So if I did this, where would the solutions be for the and here? The B. And the way you do it, the way you write it is this. Here, both A and C are correct because it's one or the other, and it's called union, and it's the big U. Okay? So let's look at some examples with these. Alright, so it says to solve this type of inequality, you'll do the same operation. So here's the thing, draw the double lines here. Start on the inside, work out. So add 2 everywhere. Divide by the 5. So I get negative 1 less than or equal to x less than 2. So this is a less than or equal to. This one's a less than. Shade in between. Okay. This is an and statement. It says 5x minus 2 is greater than or equal to negative 7 and less than 8. So this one should really be written like this. Negative 1 less than or equal to 2x minus 3 and less than 5. Because they're the same. So add the 3. Positive 2, 2x, 8. Divide by 2. You get 1 is less than or equal to x and less than 4. So the 1 has the bar, the 4 has the parentheses, shade in the middle. So those are compound inequalities dealing with and, okay? So that's been using this symbol. Now let's take a look. So it says in set notation. So how do we do it in the set notation? You just copy the set in here. So it's just like that. Okay. Let's take a look at some more. Okay, given the following graph, write the solution set using the symbols. Okay, so I look at this and I see this is x is less than or equal to 0. This one is x is greater than 3. So you can write them like here. It says all of these possible conditions can make this to be true using set notation. This is how you would do the set notation. Okay. And this is A union B. So when it says in our example, the only places that's not true is between 0 and equal to 3. All right, let's take a look at another one. It says, given the following graphs, write the solution set using the symbols. Okay? So the two that are shown here, -1, or x is greater than or equal to -1 and less than or equal to 5, and 1 is less than or equal to x are shown. In this case, both conditions must be met for the graph to be true. Okay, so if both have to be met, then instead of, we're actually trying to do this. A and B. So if you look, it's got to go here to here. So that's why it's this one. Okay? So you can log in and look at page 101 if you need to see more verbal phrases, but we'll see you guys tomorrow.